Hello,
Yes.
am I audible? Yes. Okay. So good evening, everybody. I think we will wait for another 2 minutes and then we'll start. So I got some mail regarding some queries about the previous year question and its answer. So I'll try to discuss those, but the exact question wasn't mentioned there. So I think I'll just go through all the previous year questions from week one and week two, and then we can discuss about the topics that has been covered in week two. So have you guys already go through the week two lectures yet? Just raise your hand if you have gone through the lectures. Anybody? Nobody? Am I audible?
Yes,
Yes. Yes. Okay. So nobody of you have gone through the week two lectures yet?
I have gone through week one, but not week two.
Okay, okay, good. So week one is okay. So how many of you have covered the week one lectures then? Just raise your hand. Okay. One, two, three, two. Two people, three people. Okay. Four. Good. So do you guys have any doubt regarding the week one lectures? Okay, so your hand is still raised, means you have some doubt. So am I still audible after sharing the screen? I think yes. Just- Yes. Okay. Let me share my screen again. So should I start with the week one lectures or should I start with the week two lectures? You can suggest. Because week one lectures you have covered, and I have the previous year question from week one. So it will be better if I start with the week one question series and then we can start for the week two. And these questions you have to actually answer. I'll just show you the question. Now you can unmute yourself and answer. Okay, answer is visible here. So, one of the following is or are not the popular term of reference for additive manufacturing? Anybody?
Coating technology.
Yes. Ah, okay. One is object manufacturing, another one is coating technology. 3D printing, rapid prototyping are the previous names. Layered manufacturing, can say because it's layer by layer manufacturing, and digital manufacturing is also like in manufacturing, we have a separate part for digital manufacturing and where additive manufacturing comes. So, as per the occurrence in an AIM process, put following operations in right order. So, first is preparation of STL file, then is the STL file manipulation, slicing. First is support generation and then slicing. People are keep on coming and getting that sound. Nobody is waiting here. Next is based on level, form, and accuracy. A detailed CAD model of a cricket bat is a
Complete
any
virtual
guesses?
and accurate.
Okay. So, why this animation is opposite? Yeah. So complete, virtual, and accurate. So fourth is invention of computer affected the virtual prototyping and physical prototyping both. So basically, virtual prototyping was something that you can do using computer, and physical prototyping is what people stopped using because you can do the virtual prototyping. But you can do physical prototyping easily after the additive manufacturing came in the picture. So AIM process, let's start with this one. The objects with tailored material properties known as
Functionally graded materials.
and AIM processes are inefficient for
Mass production.
yes. So next is as per ASTM standard, how many type of
Seven.
additive
Seven.
and select the correct statement.
One and three.
Three is laser power used in powder bed fusion process more than no in directed energy deposition you uses more power. The reason being in directed energy deposition, the powder and the laser both is coming at the same time. So there is there are chances of the power not getting used to melt the powder because there will be some losses. But when you talk about LPBF, in LPBF or laser powder bed fusion, the powder is spread, which is very, very thin layer of powder, 20 micron, 30 micron layer thickness. So there you need much lesser power. So that's why in DD it's more than LPBF. Then it's 7. So 2 is also correct. So in more than the obviously fat photopolymerization, it's just you need the laser to cure the resin, which needs very, very less power. Maybe 20, 30 watt can work there. Or LPBF at least 400, 600 watt is needed. So the wireframes shown in figure have
Same geometry, different topology.
so topology is something that you can see. Geometry is something where you just put the value of each arm or each diameter or length or something. So here all the radius and length are same, but topology wise, it's looking wise, it's different. The STL is not known by
Shape triangle lithography.
good, and STL format is a So it's boundary representation. Then we have few lines of a triangle from the code. ASCII code is given below. So find out the unit vector in the direction of the facet normal of this triangle. So have you tried this sum in your assignment?
Yes.
Yes. So could you do it? So can you tell me how to do it if you have done it, or do you have questions?
A cross B by modulus of A cross B gives the unit
Yes,
vector.
yes. So AB vector you can find out by doing the I minus I. Sorry, the AB vector can be get by the matrices, and then to find out the normal of these two matrices of these two vectors of AB and AC, you can go for the vector A cross B, sorry, AB cross AC divided by the value of AB cross AC. So that is basically the mod of these two matrices. Next, we have this question. This was the answer.
Ma'am, please,
So next,
please repeat this question. Ma'am,
okay.
please
So
repeat
this
this
question.
Question number
So
12.
this line you see. Okay. This is the question. Few line of the triangle from the ASCII code is given. So here you can see the vertices, like the vertices are having these 3 points. Now, if it's A, B, C, 3 points. So what is one? A is having this coordinate, B is having this coordinate, and C is having this coordinate. First, we have to find out what is AB and what is AC. So AB or AC, the formula is you have to minus the I, J, K coordinate values from each other. So this is the I coordinate, this is the J value, and this is the K. This represents the X, Y, Z coordinates in vector. So you have to minus it. So 2 minus 2 is 0. Then 2 minus 4 is minus 2. Then 0 minus 2 is minus 2 again. So now you can get the AB vector. So AB vector, the value of the AB vector will be 0i minus 2j and minus 2k. Got it till here? Now you have to find out the another line or vertex of the triangle, which is AC. So A minus C. So 2 minus minus 4. So like that, you can get minus 6. So minus 6i, then 2j, then minus 2k. So then you get the value or the vector form of AB and AC in IJK format. So now you do the mod of it to get the value of this, the cross product of AB and AC. AB and AC are two vectors. So to get the value, you have to do the cross product. So cross product kaise karte hain? We make the determine of it, and then we make the mod of that matrix. So basically I, J, K mod में लिखेंगे, and then the value 0 to 2 minus 6 2, and then normal just multiplication, you get the value of the AB cross AC, the cross product. The cross product will be divided by the value of this matrix, which is I के साथ जो रहेगा उसका स्क्वायर प्लस J के साथ जो वैल्यू होगा उसका स्क्वायर प्लस K के साथ जो वैल्यू होगा उसका स्क्वायर एंड होल रूट. So this is the value of the mod. This is the value of the cross product. इन दोनों को हम आपस में डिवाइड कर देंगे, so we will get the vector value. So this is the vector. Is it clear? Can you do it? So people have keep on coming. Can you guys also approve their entry, or only I can approve? I think only I can approve. Okay, so the next question is find out
Oh, ma'am, we can
the
also
equation.
approve.
Okay, you can also. So please approve the calls. I'm not attending that then because it's difficult to change the screen again and again. Okay,
Mm.
thank you. Yeah, find the equation of the plane in the vector form that can passes through the following points. So we have to find out the plane that has these 3 points. So first of all, if we have to have a plane out of 3 points, we have to see whether they are collinear or not. If there is a plane which passes through these 3 points, then there is a chance that this is a triangle. But it will be triangle only if these 3 points are not collinear. To get the knowledge of it, we have to do the determine of it, like the value of it. So we will make a matrix of it 220, 242, 4 minus 4. ऐसे हम लिखते हैं ना 220, 242 and minus 4 2. I can write it. How to get the pointer? Yeah. Pen. Yes. So now we can write the vector, the mod like this, or determine like this. This course includes a little bit maths, so it's better if we just revise this little tricks how to get the value of these things. So first you put 2 and then 4 into minus 2, so that is minus 8, minus 4 into 2, that is minus 8. Like that, you get the value of it. And it will come as minus 40. So it has some value. That means these 3 points are not collinear. They are non-collinear. Means it's possible to get the equation out of these 3 points, like a plane which passes through the triangle, which is having these 3 points. So for that, we have one formula. The formula is x minus x1, y minus y1, z minus z1. Niche, x2 minus x1, like that y2 minus y1, and then we have x3 minus x1, y2, y3 minus y1, and z3 minus z1. This, if you put these 3 coordinates here and put x, y, z as it is and equal to 0, then you get a equation out of it, and that is this equation. Is it clear? I hope it is. So our next question is, how many triangles will be required for angle tolerance to be 0.5 degree to represent a cylinder of 1000 radius by STL file format? So first of all, 1000 radius is this, and then we have the cylinder out of it. So whatever the number of triangles we will get to cover this 1000 radius, that triangle needs to be multiplied by 4 to get the whole number of triangles to cover this geometry. Because if you have one triangle over here, then you will have corresponding to one cylinder over the body, and that one cylinder will be covered by 2 triangles again, and then you have another triangle for the lower circle, like the bottom plane. So that's why whatever the number we will get, we will multiply it with 4. So can anybody of you tell me the formula, or should I write?
360 by n.
Yes, so 360 by n, this is having 0.5. So n will be 0.5, 360 by 0.5 degree. and that will come as 720. So into 4, so we will get the result of it, which is 2880. Then we have next question. The vertex in STL file can be shared by dash number of triangles, and an edge can be shared by dash. Answers?
2. Last option.
Option D.
Yes. A vertex in the STL can be shared, which is the vertices. So it's the point. Point can be shared by any number of triangles, but the edge can be shared at max 2.
The number of triangles.
Any doubt? No? So the next question we have, how many triangles will be required to exactly represent a pentagon prism in an STL format?
The triangles will be required to exactly represent the pentagon.
Yes, it's a tricky question. So think carefully and then answer. How many? 7. Okay. Any other answers? So how many triangles are required for one rectangle? The answer is 2, right? And we have 5 sides. So 10 we already require, right? So 7 cannot be. Either it can be 20, 15 or none of the above. So 10 we have, plus to cover the top surface, how many triangles are required? Exactly. Or minimum, how many triangles are required? Any guesses? Not guess, but try to answer.
7.
7. This is the top surface. I'm talking about just the top surface. So if I draw a triangle like
3.
this,
1.
yes. So 3 triangles are needed to cover this top surface. So 3 into 3, 6. So the answer is 16. Understood?
So none of the above.
Yeah,
No
none of the
triangle.
above. Answer is none of them.
3.005.
So how many triangles will be required for deviation tolerance to be 0.005 mm to represent a circle of 10 mm radius by STL format? So we have a formula. Can anybody tell me what is the formula?
R minus R cos 180 by L is equal to H.
R, tell me again.
R minus R minus
There are
or R
multiple
into 1
parameters.
minus cos.
So we already know. Sorry. This is the theta. 1 minus this deviation by the radius. This is the theta, right?
లేట్ అయిపోయిందని మనం చూడలేదు పొద్దున్న చూసాను యాంటిటిక్ కాసింది
I can't hear you guys. I want the answer from you, the formula. This is the theta, right?
Yes.
Yes. So next, what to do to get the number of triangles? That is n. N will be
180 upon
Some-
cos inverse theta.
yes. So 180 upon this whole theta. That will be equal to 100. So this is 100 and this is none of the above. Any doubt? This is just a simple formula. So then we have week 2 previous year questions. So if you have any doubt from week 1 topics, then let me know. I will discuss it first and then we'll move to week 2 previous year questions. Or we can start with week 2 topics first and then go to the previous year question.
Ma'am, the topic regarding continuous unambiguity, that portion is not clear.
Which question?
It is not in this question, but it was there in this year's assignment.
Okay, week 2 assignment. Okay, then we
No,
can go
week
through
one.
the week 2 assignment. Week 1? Okay, that is not here. Okay, so these are the previous year questions. So that's why I am supposed to solve the previous year questions, but you can just tell me the question that you are having doubt on. Then I can just try to answer. If I can't, then I can just search. Can you tell me the question? I think I can open the question. So let me stop the screen. Does anybody remember what was the question?
Hello, ma'am.
Yes.
The question is the attribute of a solid model that enables it to store both geometry and topology is. Options are completeness, ambiguity, validity, and none of the above.
So what you have answered and what is the, is it showing wrong?
No, actually we can't know whether it is correct or wrong now. I have marked completeness.
Okay.
But those
Just
terms,
repeat the question.
I am not having clarity about those terms like completeness and
Yeah.
validity and unambiguity.
Completeness, ambiguity,
And validity.
validity. And the fourth one?
Fourth option is none of the above.
None. Okay. The question was which stores geometry and topology both.
Yes.
Okay, let me think. Geometry and topology. It sounds like validity, but I'm also not aware of these terms. I never heard of this term. So if you guys have attended week 1 lecture, did you came across this type of?
In the notes, it is telling the completeness and unambiguity of a solid model are attributed to the fact that its database stores both its geometry and its topologies.
Okay, then these two should be the answer. Completeness and
that is unambiguity that is mentioned in the notes. So ambiguity might be wrong. Completeness might be the correct.
Then completeness will be the answer. If it's in the note, then it should be completeness. So other people were having doubt on the same question?
Ma'am, does dangling face or edge, does it mean something regarding with the topology?
Can you repeat the term?
It is mentioned that a valid solid is one that does not have a dangling edge or face. Does it mean that there is some change in the topology?
I am not sure about this answer. Sorry.
Okay.
I don't know about
dangling edge in the sense, if it is not closed, if it is open, then it is not allowed.
I can search in the notes. So it's shows the same answer that you have given. That means that the triangles are not closed. What sir was showing in one ball, the triangles were not closed because of multiple triangle interaction at one vertex. This can be the answer. So this was present in your week 1 assignment question?
Yeah.
Okay. Okay. So yeah, the answer is the triangles are not closed. Any other? So is it okay? Like is it better if I go through the notes or should I go through the questions? You can suggest me accordingly.
Notes.
Otherwise, I'll just start with the notes. Yeah, okay. I'll start with the notes of week 2 or week 1.
Week 2, ma'am.
Week 2. Yes. So in week 1, we got to know that STL is needed or slicing is needed. Now in week 2, we are studying about how STL is generated and how slicing is done. What is the correlation between the slicing and STL, and how you can rotate, and what actually you do in CAD model, how it gets reflected in the STL and slicing software, the in mathematical terms. So first is when we have a model, when we have a geometry, we can rotate it in my software. Now, if we are rotating it, then obviously if we are having a triangle, because STL is made of triangles and triangle will have vertices, means the points will have A, B, X, Y, Z coordinates. And if you are rotating it, basically if it was previously at alpha angle, if it's now at theta angle, then you can derive this is the previous one, this is the new one. So the new Z2 or Z1, Z2 will be having some relation with the previous XYZ and the new XYZ. And thus you can determine the new coordinate or the value of the coordinate or the vertices matrix or the vectors in terms of vectors. You can get the value out of the equation. But before that, you need to understand why all of a sudden you need to rotate the STA or why you want to rotate the geometry. So can anybody of you tell me why there is a need to rotate the geometry while you are studying it, first of all? Any guesses? Any answers? I just want you guys to speak so that we can interact because this is an interacting session. Okay, so do you guys know anything about support structure? Any idea?
To give support to the additively manufactured component, like similar to we give support structure to an engineering construction, we give support.
Yeah. So there are few things to be noted. First of all, additive manufacturing is a process which is able to print very complex structures in a very simple way, rather than what in casting or welding, which are unable to do or produce these complex structures. So additive manufacturing will be used in only those cases where it is needed. It's not there to replace the conventional manufacturing. So you have to see the part and that you have to decide whether you should go for additive manufacturing or casting. This is one point. This is the first point that you should remember. Second point is it's so when you will be printing something in additive manufacturing machine, you should have you should calculate the time and cost for that printing part. So how to calculate the time and cost? So basically you will have some formula, and in general cases we don't use the formula, but it's very good to know the formula before doing the software analysis, because these things are generally done in software and we don't know what is going on in the backend programming. So this is what sir has taught you, what is going on in the backend programming. And I can tell you what we do in the front panel of the software. So when we print a part, we first place the part on the build plate. On the previous day, I have told you that we will have a build plate. On top of the build plate, we place the part where it needs to be printed. So if my machine is having only 3 degrees of freedom, that is X and Y and Z, then it's a very simple process. You just place the part in such a way you have minimum number of support structure, and you can optimize the time for production as well. So when you orient a part in such a way that it needs minimum support structure, then you will end up losing less cost, because you will end up saving the cost in terms of time, because you need to have time for support structure printing. So your time will be gone for support printing, your time will be gone to remove the supports, and your cost will be gone for the material that has been wasted for the support structure printing. So, and also another thing is, after removing the support structure, in your part, there will be dents or some marks of the support. That also you need to clean. So you have to compromise either the surface roughness of your part, or if you don't want to compromise, then again you have to do some post processing in that part to remove the support dents, and that will also include some cost and time. So that is the reason why we are so much concerned about this rotation or translation. So that's why rotation and translation is very important. You need to know perfectly about your machine, how the machine works, how the machine prints. Then only you'll be able to place the rotate the geometry in such a way you need minimum support. In some cases, you can see that we are oriented the part in such a way that it needs more number of support, but your the main surface that is going to be put in the application will not be compromised, because after removing the support there will be some dent, there will be some post processing going on, and maybe in some case if I need the as built condition surface for my application, then I cannot get the as built surface if there is some support. And if my part orients something like, you have to orient the part in such a way you need more support structure to get the as built condition surface, then you have to orient it in such a way that you can get that as built surface, and you ended up putting more support, so your time is gone, your cost is gone, your support material is gone, but you will have, your purpose will be served of the as built surface. So there can be multiple cases, it depends on the application, it depends on your need. So that is the reason why we are studying the rotation and translation of this STL. Because ultimately, when we have saved the geometry in STL file format, we have saved the CAD model in STL file format, and then we have imported the file in the slicing software. When we rotate it, basically it's STL. The triangles are getting rotated. They are coordinates and their normal is going to be rotated. When you're translating it, your normal will not be rotated, your normal will be fixed, but your vertices will have different coordinates. So this is the formula you can get. So I'm not uh, describing the formulas here because it's just general math formulas. You can just get if this is x, if this is xy. So y1 will be cos alpha, and this, where is x1? So this z1 will be sin alpha. If this is the length of the L, so L cos alpha, L sin alpha. If you rotate it to the theta position, then this will be L cos theta plus alpha, and this will be L cos theta plus alpha. So there you can just expand the formula, and then you can get the new value of the vertices. So this is the this will be the coordinate after the rotation. So this formula is very important for the next week. So week 2 question series. So I will just tell you the important points from it. So this is very, very important formula. You should remember it. You should write it somewhere and remember it how you can remember how you're getting it as well. This formula will be used in multiple cases. Next, we have the rotation. So this is for 1 point. And if you have multiple vertices of a triangle, using the same formula, you can do that. And using the same formula, you can get the normal vector as well, because normal vector will also be rotated at the same form. So the same uh, rotation of the normal vector will also take place. So you can get both the values of edges and normal. Then comes translation. Translation is easy. You have to just add or subtract the value of the translation in the respective quadrants. If it's x, y, or z, you just have to add that x coordinate value for translation, and you'll get the new. So then comes the support structure. So as I said, this is called the orientation of the part. So if this is a T, if I place it like that, so this slide is very, very important. So you have to understand it properly. These are the three. Okay. There is any pen option here? Yes. No. Yeah. This is 1, this is 2, and this is 3. These are the 3 orientations I am having. So in first orientation, we have this part and we have to place this support structure. Basically, this T is having some overhang portion, and under the overhang portion, you have to put the support structure. So to print it, you have to give T1 time. This is the second orientation. Here, you will take T2 time, which is different than T1, obviously. But here, you have less support. This is more support. This is less support. So now, can you tell me which one will be greater, T1 or T2?
T1.
T1. So again, it depends on the process. It depends on which additive manufacturing process you are choosing. So any other answers? And why do you think T1 will take it more time?
More support structure.
Yes. If now I turn the question like the process, the additive manufacturing process is DD and the additive manufacturing process is LPBF, then which process will take more time? Will it differ somehow? Because these two are the metal printing processes, but different process physics. So will it differ? Any guesses?
Ma'am, in T1, we have to cover more surface area, but in T2,
Yes.
we have to have only smaller area to cover to print the metal. So I think so.
So
I think
because
T
of
is the best model, best orientation because there is no need of build material.
which orientation?
Third orientation.
But I am not talking about third yet. Obviously, it's best because you don't have to have a support structure. But right now, we are talking about T1 and T2. There is some
T2
reason
is
why
the
I'm
best.
talking about
T2
this.
is the best because minimum support material.
Okay.
Minimum support material. T2.
So,
And it does not having any overhanging like that. So I
okay.
think this is the best. T2 is the best. Because T1
So,
is having large amount of
yeah.
support material.
Yeah,
T1
you're
is best.
correct. So, in terms, T1 is best. Your explanation?
It is symmetric, no? And
Ma'am,
the
T1 is
height
best because it is
covered will be less.
symmetric.
Height covered will be less
T1 is
in
best because
less,
of the
less time. Within
okay
less time we
height.
can complete.
Okay, less time. So according to you, T1 is less than T2.
Yeah, T1 is better, superior.
Okay. So now
Ma'am, build
the
volume for
example.
the T1 and T2 will be same, but support material will be less. And then my opinion is T2 is better than T1.
Okay. So I had another question, which is if you choose DD and if you choose LPBF, in both the process will take same time or both the process will take different time.
Different
Sorry,
time.
Different
sorry.
time only.
Repeat the question, madam.
I have two processes now, DD and LPBF, directed energy deposition and powder bed fusion using laser beam. So in both this process, if I want to print these two parts, so will this T1, T2 be same in DD and same as LPBF, or the 4 times will be different? So
Different.
there were 2 time frames right now, T1, T2. Now I have 4 time frames. T1 of DD, T2 of DD, T1 of LPBF, and T2 of LPBF. This I'll write as DD and this I'll write as PBF. So all 4 time frames will be same or different?
Different.
It will be different. T2 will be taking much time.
Different. T2 will be taking much time in case of
No,
so okay,
direct energy,
T2D and
direct energy
T2P.
deposition takes more
LPBF.
time in case of T2.
Okay, so one answer I got direct energy deposition, one answer I got PBF. This is good. This interaction was needed so that your concepts will be clear. So, okay. So the answer is it depends. You cannot say that this is the best and this is the worst. By seeing this picture, by the discussion which we had right now, we cannot say this is best. Why? Because if somebody wants this surface to be intact, like they want to use this surface in a assembly in the as-built condition, then this surface is not having any support here, and this surface also here is not having any support. So that is good that both are not having any support. But if somebody wants to use this surface as built condition, then you have to compromise here more than this, because this surface is not having any support here, but will have some problem. Why, I'll tell you. But here the surface will be compromised because you have to remove the support and then you have to do the post processing. Understood? For this one geometry, you have to do the post processing here, but here you don't have to do post processing because the supports will not touch this surface. Good. Now comes the time. For DDLPBF, the time will be different, right? Here, the amount of support is more, but here the number of layer is much higher. So for LPBF, it's sure shot that this will take more time than one. So the T2P will have surely less, higher value than T1P. Is it clear? Because the number of layer is much higher. In LPBF, the laser scan speed is very, very high. So it will not have much effect on the laser scan speed for each layer to print this geometry and this geometry because it's so high. But the number of layer will be more than double in case of these two geometry in LPBF. And in LPBF, there is a lot of time for spreading because the recoater will go back, then it will take some powder, it will spread some powder on the build plate, then the laser is there. So it will have more time in recoating. And this is why if the number of layer is more, then PBF will take more time. Is it clear?
And come again. If number of layer is more,
then PBF will take surely more time. Now, if you are comparing same geometry, then if you are comparing two different geometry, one is having 100 dia and one is having 10 dia, so then obviously it will be different. But still, if number of layer is, there is a huge difference between number of layers, then PBF will take definitely more time. Like here you can see it's just reaching this part. So it's almost 3 times of this part, right? The number of layer of 2 will be almost equal to 3 times of number of layer of 1. Do you agree with me in this point? Yes. So if
Yes.
this is 3
Ma'am,
times,
ma'am, I didn't get how the number of layer of 2 is more compared to 1.
because you have
Height.
this much height of the part. We haven't gone for very hi-fi level of layering. We're just talking about normal layering where all the layer will have the same layer thickness. And if you have same layer thickness, the number of layer will be almost thrice. 3 times, I mean. So because the height is more, na, it's still here. You see, this height is almost still here. So I'm just roughly calculating, it will be almost 3 times. Do you agree?
Okay.
Yeah. So if the number of layer is more, then there is chance that the additive manufacturing will take more time in the higher number of layers because it's layer by layer manufacturing process. Each layer will not take that much time compared to if the number of layer is 3 times because it's layer by layer. So in case of DED, the scenario is a little bit different because there the powder is coming along with the laser or the arc or the wire is coming along with the laser or the arc because there can be various different variants of DED. But in case of DED, as both the material is coming at the same time, then this conclusion is not direct. I cannot conclude at this point that which part will take more time because this is having width almost 2 times or 2.5 times than this width. Right? Do you agree? Let's just go step by step. So
Madam, one more
that's why
doubt.
you could, yeah, please.
This in PBF, no, powder bed
PF,
fusion.
yes.
Yeah. For each layer, this laser scans the entire width of the bed, or only at the whatever geometry is there, that width only it
Only
covers.
at the whatever geometry. Only at
Madam?
the geometry.
Only geometry.
Only
So
at the geometry. Yeah.
if the width is less, it saves the time.
Yeah.
That is
But
scanning time also will be saved, no?
So my point is scanning time will be saved, but there will be not much higher difference because the recording time is much higher than the scanning time for this geometry. This
Yeah,
is a
no. Yeah.
so simple geometry, so it will have lesser scanning time than the layering time. And in most of the cases, this only happens because if your geometry is almost kind of same, it will take more time if your number of layer is more because of the layering process. So in most of the experiments, we see almost half of the time is gone for layering and half of the time is gone for laser scanning. It depends on geometry again. But if you're talking about some simple geometry, then and also in case of LPBA, the support structures are scanned different way than the part because support structure need not to be very dense. Otherwise, it should have some rigidity, but it need not to be fully dense part. Otherwise, it will be difficult to remove.
No.
So that's why
Actually, it's a sacrificial structure.
Sorry, can you repeat?
No, it is like a sacrificial structure.
Yeah, it's a sacrificial structure. So that's why we will not be concerned about the 100% density to be achieved for support structures. So that's why the scanning time for support structures is even lesser than the part scanning. It will be fast raster or fast scanning for the supports. Very fast, faster than the part scanning. So that's why ultimately the time for scanning will not have that much difference than the layering process. So that's why, and also there is another point. So if I talk about the cost, then for LPBF, you need to pour the powder beforehand before starting the printing. If you have this much big part, then you have to put that much powder also. So that means you have to put 3 times more powder than this part. So I will repeat. So in the LPBF process, first we pour the powder. First we put the powder in the powder keeping container. Then we just close the chamber and we start the process. If I'm having very high high height, like very long height part, then I have to pour the powder depending upon the part height. We calculate the density of the powder, we calculate how much powder is coming per layer, and multiplying it, we pour the powder and little extra. So if your part is having if your part is very high or long in height, then you have to pour more powder. Then you have to buy also more powder. In terms of powder also, it will be more costly. You understand this point?
Yes.
In case of DD, so you put powder in the powder feeder, but your powder will be coming at the time of process only. There will be lot of wastage. So in case of wastage, in terms of wastage, DD waste more powder than LPBF. But as LPBF powders can be reused after sieving, but the DD wastage powder is not easy to sieve and reuse. So wastage is more in DD. So that's why uh, there is this one problem that it will waste more, but at the same time, only that much powder will come in case of DED wherever the part needs to be printed. So it will not cover the whole area like LPBF. So you can reuse the virgin powder which is present in the powder feeder. But in case of LPBF, you have to sieve all the powder and then print it again. And if your powder is very sensitive to heat, then you can have heat damage in fewer part of the powder and you have to throw the powder. Even the powder is good. So that's why this wastage, from wastage point of view, DED will have more wastage, but again, you have to put more powder itself in DED, in LPBF. So your cost will increase. Also, LPBF apparatus are more costly than DED apparatus generally. So from that point of view also, in LPBF, it will take more time in this part than this. And for DED, it's not a direct answer, which will take more time. But I suppose because of the higher height, this will have more chances to have more time for printing. So this is the comparison between these two orientations. And the third orientation is pretty simple because you are sacrificing this whole part, but you will not have any support. So your wastage is less. You have to just put a little support below this. You can put, you cannot, you can avoid putting. It depends upon you because at the time of cutting from here, you will have some 2-3 millimeter wastage depending upon which process you are using to cut it. So if you do not want to waste material, then you have to put little support below it. There is another point that I want to mention. If this part, sorry, lines, if this part is, for example, 100 millimeter, like this is a large part, 100 millimeter is a large part for us. So if it's a large part, then it's better to put a support beneath and then print the part. Can anybody guess why? Because there is no overhang structure to put the support. But I'm still saying that it's better to put the support and then print the part. Any random guesses?
Sorry.
Or it might get glued to the surface, bottom surface.
Yeah, so it will be glued, not glued, actually metal. If it's metal, then metallic bonding will be there. If it's polymer, then just will be glued to the surface. You have to just cut. But why I'm saying that still you should put some support and then print the part. You can remove the part easily and support is a wastage. Then why I am telling that it's better to put the support, even if it's a wastage.
So if you put support, then it is of less dense, and we can easily in the post processing we can easily remove that. Is it like that?
Can you repeat your answer? If it's less dense, which thing?
If the support is of normally the
Yeah,
the
yeah, it's
actual
less
base
dense.
will be, the support may be less dense, so we can in
Yeah,
post processing we can easily remove it.
but
So
my
the
question, yeah, you
bottom
are
portion will be
correct. Then why we should put the support? We can avoid the support because there is no overhang portion.
removal will be easy.
Why removal will be easy?
Oh, ma'am, for
Because of
final
the less
finishing,
density?
for final finishing, it is better to have supports.
For final finishing, actually, support structures are not good. Because even after cutting the support, there will be some dents of the support that again you have to remove. So it's more work if you are putting support. So the answer is
To save the
whatever
base,
additive. Yeah. Yes, please complete.
yeah. No, the laser it may
Yeah.
cause any harm to the table. Which
No, good thinking, but it's not like that because if you are printing support also, the laser is remelting the build plate. So the answer is when you print a large part, a large surface at the bottom. So basically, large surface will have large heat content. Because if you are using DD, if you are using LPBF, or if you are using VAT photopolymerization, or if you are using FDM, any process you are using heat to melt the metal, or you are using heat to sinter the powder. So, or you are using heat to cure the resin. Everywhere heat is used. And if your surface is very large, like 100 cross 100 or 80 cross 80, there will be large heat content in that particular surface. And subsequently, if you're printing layers, if you're printing 50, 60, 80, or 200, 300 layers of this big surface, one on each other, with that large heat content, ultimately, your residual stress will increase in that part. Residual stress means you put a lot of heat, but that heat didn't get much space to escape. And because of the heat, the part wanted to expand, but it could not expand because of the layer by layer manufacturing, and because of which it is having some stress inbuilt inside it, which is residue, so residual stress. So because of this large heat and residual stress, when you try to cut the part from the build plate, it will bend. The part will get bent and the surface will get bent. The surface may have some cracks as well. So ultimately, your part will be of no use. So to get rid of it, you have to heat treat it. So there will be some heat treatment processes. Basically, you will slowly heat it to some extent and then slowly cool it down. Because of this process, that stress will get some space inside the furnace to escape by in terms of heat. So it will release its own stress in the furnace at the time of heat treatment, and because of which afterward you can cut the part and it will come out smoothly intact as it is. But if you are putting support structure beneath, then on the build plate, you are not putting that much heat and your layers are not adhered to that big surface. So it's happening, and the support structure has another role, very vital role than supporting the overhang structure. The support structures are needed to dissipate the heat to the build plate because there will be columns. So it's same like the bridge concept. Rather than making a block, it's better to put the rods in a particular way, like trusses, and then you have the bridge structure. So same, if you put the support structure, these are small cylinders. It will act as a heat dissipation site for that particular layer to the build plate. So the layers will dissipate the heat faster. So that's why now when you cut the support or cut the support to cut the part from the build plate, your part will not get bent. You can easily remove the part without heat treatment. So that is the reason why it's still better to put some support beneath this part. Is it clear?
Ma'am, I have one doubt. On
Yeah,
basis
sure.
of on basis of DED deposition, whether 1 and 2 is taking more time.
Okay, that answer was not straight. So in DED, as the material is coming at the same time with the heat source, the answer is not straight. That this part will take more time. But I suppose that 2 number will take more time because of layer. But again, it's not easy like LPBF to say because the DED head needs to move from this to this to this to print the supports. But it's not same as LPBF. The DED head will move, so it will have some inertia. It will have some uh, velocity restriction. So that's why it will take more time for each layer. So that's why you cannot say that this will take less time or this will take more time. Indeed. Am I clear?
Yes.
Yeah, because it's different process. You cannot say this will take more time or this. But in LPBF, you'll surely say for this part at least that this will take more time. And the reason for support is clear. There is two vital role of support to support the
And
overhanging feature and to dissipate the heat.
ma'am, in terms of LPBF, you were telling that if the number of layer is more, it will take more time, right? So,
Hmm.
but we are considering only the height of this column. Why,
Hmm.
if we consider the the right part also, then don't we take that into consideration?
Okay, so right part means 3, third
No, not
configuration,
not right part. In
left.
the second figure itself, the part projecting
Hmm.
to the right, that portion are we not considering?
No, it's like the surface area. This is the surface area was for this part. This is the surface area for this part, right? Both the widths are same. The length is different and the height is different. Width is same, so do not have to consider. Then lengthwise, it's more. This length is more than this one. Length is this thing. But to scan the length, the laser scan speed is already very high. And for the support printing, if it's even higher than part printing. So you do not have to have, you will not have large difference in the layer scanning of these two. It will be very little. But as the number of layers will be almost 3 times, and in LPBF you have the recoating time also, that's why this will surely take more time.
Even though the surface area is less, since
Yeah,
the height
yeah.
is more.
Since the
Okay.
surface area will not, because this is just almost half, right?
Hmm.
Half of it. So it
Yes.
will take less than half of the time. Like this part, to print one surface of this will take less than half of this, because the support structure will not take much time. Support printing is faster.
Okay.
Okay. So that's why I'm saying that this will take more time because of the layering. Done. So let's go to the next. So orientation wise, this will be better orientation because it's not having any support. And these two depends. If we have to have this surface to be intact, then which process you are choosing, you can choose the part orientation. So now, when do you think the support is needed? Obviously, if there is an overhang portion, and that overhang is coming from the triangle itself, because the whole surface is covered by triangles, which is making the STL fine, and the triangles will have a normal. And if you have a normal which is facing downward direction, that means that particular facet or that particular triangle needs the support beneath it. So if it needs the support, then the adjacent triangle will also need the support, because one triangle is very small. So now how many triangles will need the support, that you can calculate through a formula. But again, the formula you can learn from this simple equations. These are just mathematical equations. So these are simple to understand. But the main thing to understand is why this thing we are doing. You have to remember all 7 types of additive manufacturing have different process physics, because of which it doesn't mean that whatever process you are choosing, the support will be needed. There will be some process which can print one geometry support less, but other process will need to have support for the same geometry. Right now, I'm not having the part with me. Next class, I'll show you. I printed one part in VAT photopolymerization, and it was a supportless printing. But that was the only process that could print the part supportlessly. But the other all processes needed support for to print the same part. So that is the difference. Your if somebody asks you that I have a part and I have an overall structure, do I have to put the support? Your answer should be which process you are interested in, which material you are interested in. Because depending upon the material, you will choose the process, and depending upon the process, you have to choose whether to go for support or whether not to go for support. So this is the reason why we are talking about this choosing of the facet for support structure. So again, if you have a part like this, and if you print like this is T, this T is having some value 10, 15, 20 millimeter or 2 to 5 millimeter. And then it looks like this. If your layer is also looks like this, then you need a support for this overhang part. But if your part looks like this, it may happen that this length is not that much that you have to support. You have to put the support. What I mean to say is for the support, overhang length and overhang angle are two important parameters. So you need to check the overhang length first, and then you need to check the overhang angle. Depending upon the process, depending upon the state of the art, this overhang length and overhang angle changes. It may happen that more than 10 millimeter overhang length, if you are having that, then you need to have a support in DD. But you don't need to have a support in LPBF till 20 millimeter overhang length. So this type of variations will be there. So that's why your first question needs to be which material and then which process. So this is the formula. You can just note down this formula, especially it's very important for support structure calculation. Using this, we have no, we haven't solved anything yet. So we will solve more problems using this formulas. So then comes this structure. So it is also important that if you have a structure like this, then your support will be connected to your part itself. Not only this surface will be sacrificed, this surface will also be sacrificed, this surface, because your supports will be connected like this. And it will be connected to this surface. So that's why it's very important to orient the part. If I orient the part like this, if I just orient the part like this, then you just need to have some support here. But again, it depends how much length it is having. If it's minimum than the overhang length to be having support, then you can just avoid putting it. Then comes the facets, which needs the support structure. So if this is the facet, this is the formula, you can get the angle or the length, and your sum, this is a like point you need to remember. So in the sum, it will be given that this much overhang length can be self-supported, and after this you have to have a support. So then you need to calculate how much angle or how much supports it needs to be given, like how much volume of the support needs to be given. So this type of sums will be there. The same type of sums. So that's why I'm not discussing it, because you see the videos, it's very nicely demonstrated, because sir is giving some examples, real examples also that I'm not having here. I'm not having any video, so that's why I'm not discussing this formulas. It's better to understand from there if you see the video. So it's just showing that if this is the facet which needs the support, then you need to draw the reflection of it on the surface or projection of it on the surface. And the projection will have the support. But for the projection, you need the area and the height both, because you need to have the volume of the support. So then you can calculate the volume of the support or the volume of the portion, volume of the facet which needs the support. But it's not true that if your volume is coming like, for example, 3000 millimeter cube, it doesn't mean that you have to put 3000 millimeter cube support. You can print, you can put tree-like support, which will look like this. Which will have some branches to be self-supported, to give you the self-supporting. And like that, you can minimize the volume of the support and still can support the part. Is it understood? You can have this type of supports. So you can save some surface of it, because you have to compromise the surface, and you can save the money for printing the support and the cost for the powder or the wire as well. Then comes this rabbit. So this rabbit need to have support in all the part, but again, you can select the type of support. There will be block of support, there will be contour of support, tree type support, cylindrical type support, teeth like support. Lot of support structures will be given, but it's not true that any support material, any support structure you can use for all the parts. Different part needs different type of support. This part is having little overhang, but again, this portion is self-supporting. If you put the support here, you don't have to put the support here as well. If you put support here, it will be self-supporting. If you can orient the part in such a way that your part will be self-supporting, then again, that is also an option. Then comes the build orientation. This is the facet normal coordinates for this part to decide whether to put the support or not. There are some nice MATLAB codes that were shown in the video. I'm not having those MATLAB codes. You can go through the MATLAB codes, and if you are able to, then you can make the MATLAB code and see. this is an important formula to note down. This is the area of the triangle, how to calculate the area of the triangle. Because if somebody gives you one question that these are the triangles, need the support, then you need to calculate the area of the triangle from the vertices, and then you need to have the height of the triangle and then multiply the area into height. This formula is true when it's two, like x and y coordinate. There is another formula I'll give you for x and z and y coordinate. Then there is this methods for support generation. One can be just see whether the not see, but calculate which facet need the support. Other method is the containment method. So containment method says you need to draw the contour of each slices. So after slicing, we will see whether it needs support or not. Or before slicing also, we can see whether it needs support or not. But you can slice the geometry in such a way that it doesn't need support. This is also possible. From last week's lecture, if you remember, there were techniques where you can do the adaptive slicing. Adaptive slicing matlab in one part you are putting more layer thickness, and in one portion you are putting less layer thickness. If your layer thickness is less, then you need less support, but you need more time for printing. So you have to compromise one thing. So in this method, you have sliced already the part, and then you are having the contours. Contours mean in one slice. This is one slice. What is the projection of the part? So if you join or merge all these contours together, you will have the whole projection of the part, and that is basically the support structure. For example, if you're talking about this nth slice and n-1 slice, then this nth slice, this n- slice is first layer, nth slice is the second layer. So the second layer needs some support in this area because this area is not covered by the n-1th slice or layer. So this is the contour method by which you can calculate which area needs the support. So if you see this photo, it's better. So if this is one layer, this is the second layer. This second layer ka jo ye wala portion hai, it's not covered by the first layer. So that's why this portion needs the support. Or if this part is the up layer and this is the next layer, then in dono ka minus jo hai, this portion needs the support, which is having over here. So you need to have this much support only. You don't have to have support in the whole area, not in the whole contour. You need to have this much support. So this is another technique by which you can calculate the support. This is just an example. So here also in the layers, you can just put the projections, and I'll tell you one example. So if you're talking about this thing, so this is one layer, and this is another layer. And if your layer thick, sorry, if your layer thickness is enough to self-support this portion, then you don't have to put any support. Or if your process is flexible that much to self-support this portion, then you don't need to have support till here. And you just need the support here. When your support is fully in line with this inclined surface, it's called the stale support. And when you put the support in just the overhang portion, fully overhang portion, it's the normal support. So now you have the optimal orientation. So as I said already in the first slide itself, you need to optimize the support in terms of time and cost. Everything is all around time and cost only. So cost minimization model, support minimization model, and multi-objective model. These two models I have already discussed with you. So in case of cost minimization model, you have the total cost, which is equal to pre-processing, machine utilization, material cost, and post-processing cost. In case of cost
Ma'am, sorry for interruption.
minimization. Yes, yes. Yes, please go ahead.
As per last week discussion, if you have said about some problem concepts, then it will be useful.
Yeah, okay. So I can just show you the problems which were there in the previous year question, and then I can tell you the formulas which needs to be used for that. Is it fine?
Yeah, sure, madam.
Yeah. So, okay, let's go ahead with the questions then. So our first question is, few lines of a triangle from the code ASCII format of this STL file is given here, which is saying the vertices. Now you need to rotate the triangle into 30-degree clockwise about z-axis and then 60-degree counterclockwise about y-axis. So can anybody tell me how it should be done? It's very easy problem. First, you need to put the cos 60 and sin 60, sorry, cos 30 and sin 30, and then you have to put the formula of r theta z, and then you have to put the sine. For this, it will be minus, then sin 60, cos 60, and then you have to put the formula of r theta y. You have to multiply it with the coordinate of these, multiply both the things with these coordinates, and then you'll get the result. Is this one? The formula is very easy. We have already talked about the formula. It's this one. It's this one. This formula, you have to use it. And then just put it like this. You have the vertices and you have the result. Just multiply it. Okay.
Ma'am, we have to keep all the thetas in one, or one by one we should keep.
No, one by one. First, you need to keep r theta z, then r theta y. Then you have to multiply this to r theta z and r theta y like this. You have to multiply this two like this and this. And then you'll get another matrix of 3, 3, 3. And then you have to put one vertex value and this 3 cross 3 matrix. And then when you multiply it, you will get 3 points like this. Understood? Multiplication is so easy. Yeah? I have solved it and the same result is coming.
Yeah.
So,
You have to follow the order, and every time it should be three multiplication.
Yeah. Next, we have few it's few lines of triangle from code ASCII. It's given again, and it's the same question again. It's just 90-degree counterclockwise, and then about y-axis it's 90-degree counterclockwise. Again, it's z 90-degree counterclockwise. So first you need to put the r theta x 90-degree, cos 90, sin 90. Then it will be r theta y 90-degree, then r theta z. Then you have to multiply r theta x with r theta y, then that answer with r theta z. And then if you just multiply it with these vertices, you'll get the answer. Okay, it's same formula. It's same question. Cool. Next, we have again same question, but it's translated. For translation, it's way too easy because it's just you need to put, I'll write here. You need to put these vertices in this manner. 1, 1, minus 2. It's for, sorry. 1, 1, 0. This is for the vertex A. Okay. Now everything will be translated +1 in x, +1 in y, and +1 in z. So A will be +1 in X, then +1 along Y, and then +1 along X. Okay, X may it's 2. So 2, 1, 0. Everything will be translated in all three axes. So you have to just plus it. So the answer will be 3, 2, 0 for A. So this is the translation of the A vertex. The same way you can do it for B and C. Now you have to do what will be the vector corresponding to the new facet number. For vectors, again, it's A cross B, AB cross AC. AB is simple. You have to just minus it with A to C and then cross product. So it's just vector cross product, and you have to divide it with the mod of A cross B. So it's just the multiplication value of the A cross C matrix, like x square plus y square plus z square root over. X, Y, Z are the values which are there with I, J, K coordinates. Understood? The answer should come like this. For one facet, I have done it and it was coming. Good. You can just note down the formulas and then you should practice it. And at the time of practicing, if you are not getting the same value, just let me know. 4 is few lines are given again. If the triangle is translated, it's again the same formula. It's translated in plus y, +1 in z. So now it's, sorry, then +1 in y. So first you have to translate it. So this is the matrix you need to plus with these vertices. So the A vertex will have this vector 1, 1, 0. And you need to plus with this new translation. When you get the three vertices values, then you need to rotate it in Z direction. So for the Z direction, you already have R theta Z equations, like the formula with the, I have written the formula. So for Z, it's cos theta Z minus sin theta Z 0, sin theta Z cos theta Z 0, and 0 is 0, 1. You have to put that value. When you have that value, now you need to multiply it, like the new A will be equal to the matrix that you are having, multiply with the A matrix that you're having. A is the new A that you got from the translation. Okay. The same will happen with B and the same will happen with C. After that, the same thing, A cross B. Okay. Okay, here you don't have to do A cross B, A B cross actually, because you need just the vertices. So it's done. And this should be the answer. In an AIM process, the triangles of STL file with facet normal at an angle more than 120 degrees from the build direction require a support structure. A few lines of the triangle from the code, the ASCII format is given here, the same code. So thus the triangle requires support structure in Z direction. So we need to calculate. So the formula is first at angle cos theta. Do you remember the formula by chance? Cos theta is dot, not cross. So this is the formula of the cos theta, where n is the normal and m is the direction, build direction. So for example, m value will be 0, 0, 1 because the build direction is z direction. Okay. And the n will be equal to AB cross AC. AB you can get from vertex like 1 minus 1 like that. And AC you can get similar way. And then you have to cross it like the vector I, J, K. You put the AB value here, you put the AC value here, and now you get one thing. And then you can just multiply it with this one. So it will be just K vector. It's dot product. So Z equal to K vector because it's the value is 1 and it has only value in K coordinate, not in IJ. So like that, you can get the theta, which will come around 126 point something.
Ma'am, I have one doubt. In this AB, ma'am, am I audible? Ma'am, am I audible? Hello? Ma'am, am I audible? Ma'am, I have
Sorry,
one doubt. In that,
yeah, my network got disconnected. So yeah,
yeah,
yes,
actually, in the
correct.
previous problem, your matrix AB vector
Yes,
AB vector plus AC vector,
yes.
you have written, no, madam? Not this
This.
one.
Yeah,
This
I
one.
wrote, but I didn't save it. So yes, you can ask.
Okay, AB vector means the vertex 1 and 2. AC
Two,
vector
yes.
means vertex 1 and 3.
1 and 3.
So
Yes.
if we multiply that, we'll get 3 by 3 matrix, no?
Yes.
Yes.
No. You will not multiply it. It will be like I, J, K, and then the value of AB, and then the value of AC, and then you will get a equation of I plus J plus K.
That value of AB is nothing but formula that x2 minus x1, x3
Yeah,
minus
yeah,
x,
yeah,
like that.
yeah.
The same way what we have solved in assignment 1, like that only, no?
Yeah.
Okay.
Same.
Thank you, madam.
Yes. So now for this question, you already have the answer because from the last question, if you could solve it, we already know that without translation or rotation, we need the support structure. So that's why I'm not going for it. Otherwise, if your answer is not this one, then you need to just rotate it with 90-degree clockwise in X direction or Y direction or translate it and see. And the translation rotation formula I have already discussed. So next is the solid sphere has to be built in an AM process. Yeah. So this is the hint that I'll put for this question. This hint is there in the PPT. So I need you guys to solve it. And this is the diagram that I'm putting for you for this question. So there is a solid sphere. You need to print the solid sphere with STL. And then if it's more than X degree, because it's increasing the degree, like if you draw the tangent, at which point you do not need the support, or till which point you need the support, that is X degree. So this is the diagram. Now you have to find out. For more reference, I have put this formula as well. With the help of this formula, you should be able to solve it. The hint is A is the previous one and A dash is the one that needs the support. So if you just do A dash by A, then you can get the X because you already have the formula. So that is the solve, that is the solution you should do. Next, sorry. Next question is, in an adaptive slicing, a semicircular duct from inner diameter radius 8 mm is given. So the formula is pretty easy. If this is the thing, layer thickness minimum, then it has a formula like this. You can note down the formula. Using this, you can find out the D, and D is our answer. Next, we have consider the following orientation of the CAD model. And now, which orientation is good? So I need the answer from you guys for this question, please. Quick. Answer, answer. This is so easy only. So it's the fourth orientation. The area of the base surface is maximum. And all other orientation will need the support structure. So now we have next question. In AM process, the maximum possible layer overhang can be 1.5 mm. So as I have mentioned, either it will be in length or will be in angle. So the build direction is plus Z. The critical value of the Z component of the facet normal of the triangles of an STL file. Beyond that support to be required is minus 0.75. The minimum possible layer thickness. So there is a little bit misalignment in the text. You can just see from here. So this is the formula to be used for this math. That's why I've just written the formula. From this, you can easily find out the T. I have already calculated the theta. This is the first option, 1.32. Next is this. So I mentioned one formula, if you remember, from your question from the PDF. So these are the triangles. When you need to calculate the area of the triangle, it's different from 3 dimensions. So the question is, the following 3 triangles require the support structure. So how much will be the volume of the support? So you need to find out the area of the support. So these are the area and the average height of the support, like average height of the facet. So this is the height, and this is the base, and this will be the area. So you need to calculate it. And after calculating it, you'll have the area and the base. This is the formula already for AB and AC. You can just multiply it for the base value and for the area. And then you have the 2 into area by base is height. You have to just multiply the area with the height of each triangle and then sum it. You'll have the volume of the support. By this, your answer will be 4500. Next question, we have the object shown in figure has to be fabricated by an additive manufacturing process with a thickness of 10 mm. So if I use the containment method, that means I need to draw the contours. So the smart way will be the biggest contour. I can see this is the biggest contour and it has 10 mm depth. So 30 is the width and 10 mm is the breadth. So obviously 30 into 10, that will be the area. So it's the projected area to be supported, that is 30 into 10 height of the object, which is 200, minus the volume of the object, which is this. So the answer will come this one. The geometry is complex, the formula is easy.
Please
Yes.
explain once again. Please, I could not able to understand. You can mark and show what is the code level.
Okay. Yeah, sure. For this question or for the previous question as well?
This question only.
Okay. So even if your structure is very big, this is the biggest portion of the structure, right? This area. I can see the structure and tell you this is very small. This is very small. Like the width wise, this is the highest width of the sample. So if I am following containment method, that means I have to merge all the contours of one part. And if I start contouring the part, obviously this will be the contour for this layer. This will be the contour for this layer. This will be the contour of this layer. So obviously the largest contour I'll get from this portion. That is simple.
Yes, ma'am.
So that's why in containment method, ultimately I have to sum all the areas of the contour. So obviously the sum will be the biggest part, which is this one. So I have to just get the area of the projection of this contour, which will be nothing but 30 mm, and the thickness is already given 10 mm. So 30 into 10, which is 300. So 300 is the area, projected area. Now projected area will be multiplied by the height of the object, which is 200. So 200 into 300, whatever the value will be, you have to just subtract it from the 57,000. And that will be the volume of the support.
Ma'am, so the
Understood?
support will be there in as much area as there is base material, is it?
Yeah. So basically, you need to have support. According to containment method, you need to have support in the whole area, which is not required and in real. But according to the method, which is useful for other parts, you will have the value of the support, volume of the support. The largest area you need to find out. The largest area will be multiplied by the whole height of the build, the part, and then you have to subtract the volume of the object.
Okay.
Next is, this question is again very tricky question. So I need you to be very concerned about this question, because here it says the object shown in figure has to be fabricated by additive manufacturing. Consider the optimal method, which is in caps, of support generation from contours. Find out ratio of volume of stale and fresh support. Stale support is something which will be attached in this portion, and fresh support is something which will be attached in this portion. But if you understand the process along with doing the multiplications, you will understand for this part, I do not have to put any stale support. Why do I have to put any stale support if I'm putting a fresh support? Right? Do you agree with my point? You only have to have this fresh support in this part. You do not have to have any stale support. So the stale support is 0. So the answer is 0. This type of tricky questions will be there.
Ma'am, is there?
So
Ma'am,
before,
once again, please.
Yeah. So in this geometry, if you see the geometry carefully, then you'll understand that if you put a fresh support here, you do not have to put any stale support here. It will be self-supported. This geometry says it, that this will be self-supported.
But the normal vector is facing downwards, then we have to support, no, madam.
No, it's not true, because as I said, so there will be the angle and the length of overhang, which needs to have a threshold value. Then only you need the support. Otherwise, you don't need the support. Now, the value we
So
don't
that means
know from
theta,
this
yeah, as
portion.
you're telling theta is greater than 120. That's what.
Yeah, yeah. It's not 120 always. It depends on the process. I am repeating it again and again. It depends on the process. But for the simplification, we are taking it 120 here. But not for this problem. For this problem, you don't have to consider anything. You just put a support from here and it will be self-supported. This is the normal understanding that you have to have if you're dealing with 3D printing. Okay, so
Okay.
when you see multiple parts, you'll understand slowly. So it's not like wherever there is a tilt, I have to put the support. It's not like that. If I put a fresh support here, I don't have to put any steel support here. I have to just put the fresh support here and it will be self-supported. So that's why the steel support is 0. So the answer will be 0. I'm going to the next question. So it's a big question. So a part to be manufactured by an AM process has been examined in 3 angular positions: orientation 1, 2, and 3. Now it's again a very, very simple question. The only thing it's very big. So for one orientation, I'm doing the sum for you. You have to do the same thing for all 3 orientation and find out what is the answer. So in this sum, you'll be given the projected area on the base and the height of the triangle. If you remember from past 2-3 slides, the volume of the support is all about the projection area of the base and the height of the triangle. So if you multiply these two together, then you'll get the volume of the projected volume. And projected volume is nothing but the support volume. So if you sum all the things, you'll get the support volume. And you'll get the same thing for all 3 orientation. And the answer is orientation 1 and 3, because these 2 will have the same amount of 12880 volume support, whereas the second orientation will have little bit more than that. Is it understood? It's a very simple math.
Ma'am, both the orientation will have
Yes.
the same value of volume.
Like for this math, it will have the same value. For this problem,
No,
it came same.
no, I could not understand what they're asking. Examined in 3 angular
Okay.
position.
So yeah. I'll tell
Corresponding
you.
to this angular position, following was observed. So the
So
orientation 1,
it's,
orientation 2, they're given. And
yeah. So
what is the expected thing they're asking? I could not able to
I'll tell
understand
you.
from this question.
So if you see the table, then what are the data which is available? Overhanging triangle, number of triangle which is overhanging. Okay. Sorry. Yes, triangle which are overhanging. Then so in the orientation 1, you have only 5 triangles which are overhanging. In orientation 2, you have 10 triangles, and in orientation 3, you have 7 or 8. It's not fully coming. So that much triangle are overhanging. Now you have the projected area and height. So what you can determine is you can determine the support volume easily. You have to just multiply these and sum it up. Okay. So if you sum it up, like the question is actually incomplete to some extent, but what I can observe from this question is I can easily find out the support volume from this because I have to just multiply it. So when you multiply the projected area and the average height, you get the volume. You add all the volumes together, you get the total support volume.
Ma'am, it gives the total
Okay.
volume of the support or the total volume of the object.
Of that orientation. So this is for orientation 3. You have 3 orientations here. So you can simply 30 into 40 plus 40 into 25 plus 20 into 5 plus 60 into 75 plus 80 into 75. If you do this, you'll get some value. Okay.
Okay.
So that is the support volume. Because overhanging triangle से हमको projected area and height Milake, we are getting this result. So that means that is the support volume. For again, these 10 over angle triangle, I will get the support volume.
Yes, that I understood. What is the question they are inferring? What they want to infer
Yeah,
us
so the
from this
question was
orientation?
incomplete. I understand. The question is a little bit incomplete. I have to check whether I have put other question, like half of the question and forgot half, or they have mistook putting half of the question. So that I need to check. But for this type of questions, I am just showing you the possible solutions. Okay. So as the support volume will be less in case of these two, I'm correct. I'm giving my answer as orientation 1 and 3. Like this will be the better orientation than 2. That is the answer I'm putting. But the question is like which part you will consider. Is it clear?
Because of the less support volume.
Less support
right?
volume. Yes, in terms of support structure.
Yeah,
Support volume.
that's what. I think the question is incomplete. That's why we are
Yeah,
confused.
I think the question is incomplete. So match the best fitted. Uh, so it's A is machine alloyance required in positive tolerance. If you give positive tolerance, means you're putting some material to be machined later on. If your object profile dimensional preservation, then it's adaptive, because in adaptive you slice in such a way that you don't have to have extra material or less material in any of the parts, and thus you can reduce the support also. Slicing over non-planar surface is conformal, because in that case obviously your machine is having more than 3 degrees of freedom, and works dipping post processing is a negative tolerance, because you have put less material onto it. So 17 is an object built in Z direction. Few lines are given. How many points need to be recorded for an intersection between triangle and slicing plane? So if your any of the Z, excuse me, if so if your any of the Z is less than 0 or 0, then you need to be concerned about those triangles. Otherwise, you don't have to be concerned about those triangles. And here, there is no triangle which is having 0 or less than 0 Z coordinate. So, no points need to be recorded. Cool. Then, next question is an object built in Z direction. Few lines are given. Sorry, few lines from the SKI code are given in option. Which of the triangle participate in the slicing procedure for Z equal to 1 or 2? Okay, so here the same thing. So if they are participating in Z equal to 1 or 2, that means their one vertices are equal to Z and other vertices are at least less than 1. Same thing if their one vertices is having Z equal to 2 or other along with other vertices which are having less than 2. Okay, so the possible answer is the last one, because here we have this Z1, which is, here it's less than 1. So already some of the portion is down this line. If this is Z equal to 1, this is Z minus 1. So it's already down the plane. So that's why. Next, we
Ma'am, I
have
could
an
not able to
object.
understand. Please explain once.
Yeah. So if I have a plane which is Z equal to 1, okay, and Z equal to 2. Now the question is which points need to be recorded. So only then your point needs to be recorded when your part is having less than 1 or less than 2. So in this option, your triangle, one point of your triangle is at -1 and then 2, 2.
Ma'am, why
Okay,
can't
so
be option 3? It is -6, no?
yeah. So right now I am just seeing this. So option 3 should be correct as well. So it's also -6, which is somewhere here, and then this. So -1 and then 2, 2. And this is also no. Option 3 will not be the correct answer. Why? Because the question is which of the triangles participate in the slicing procedure for both slicing plane 1 and 2. So here it's having -1, but this is the Z2. Sorry, I have just done. This should not be the Z2. This should be the Z2. And one triangle is having Z equal to 3. Like that means the triangle looks like this. In this case, the triangle is having -6, but the other coordinates are like this. So it's not intersecting the Z2 because this is less than 2. Is it clear now? In this case, it's intersecting the two number plane, but it's not intersecting the one number plane because no one is less than 1 or equal to 1. Here, it's equal to 1, but again, it's not equal to 2 because it says both the plane needs to be intersected. I thought one plane. Understood now?
Yeah, ma'am. Thank you.
Yeah.
So last
So an
option, right?
object is only last option, right? Because otherwise it's not cutting both the planes. If it's one plane, then the 3 option will be correct as well. So it's easily you have to read the question carefully. An object is built in +z direction by A. Few lines
All the
from the
questions are
triangle
like
from the
that only. We should live very carefully.
yeah, you should read very carefully. Otherwise, previously I was trying to solve the stale support for that geometry, but the stale support actually not needed. I was trying to solve it, but then I realized the stale support is not needed. There is a fresh support. So that's why you have to see the question very carefully. So the 19th is that ABC is given. The direction of the building is +z. Find out the intersection point between the triangles and the slicing plane. It's very, very simple math. So basically, for one axis I can show. So for A, B, and C, you have the coordinates. That is 3, 6, 0. Then you have 2, 1.5. And then for B. And for C, you have 5, 2, and 1. So now it says which slicing plane. This is the slicing plane 0.5. Z equal to 0.5. So that needs to cut this slicing plane. So first you have to find out what is x minus xa by xc minus xa. And this is the equation of the plane which is passing from x, c, and a. And that needs to cut z equal to 0.5. You'll have the x equal to 4. Then similarly, y minus ya. I'm just taking one vertex and calculating yc minus ya. That equal to 0.5 because that is the plane it needs to intersect. And by that, you will have y equal to 4. Already I'm matching with one answer. So similarly, z minus za, and then you'll have 0.5. Similarly, if you do x minus xb or xa, then xb minus xa equal to 0.5, you will get 2, x equal to 2. So like that, this option. So a little bit of I have done here as well. Yes,
Ma'am,
please answer.
Ma'am,
is it
why
that-
we are taking x minus xpa, xb minus xa, and x minus
Because
xa, xc minus xc?
I am considering this x, AB and AC vertices. We have two vertices. So I am forming a triangle with this with an X. so that I can get the x value which is cutting this plane. This is the plane which is having z 0.5 but x and y 0. So if I just can write a equation of a line which is cutting this plane, then that is the x coordinate I am having from this equation. Am I clear? So
So
basically
we should
I'm
keep
taking
y
this
minus
line.
yb. Again, y minus yc by yc minus ya. We should calculate.
Yes. So y minus y a by y b minus y a equal to 0.5. Understood?
Ma'am, why are
You'll
we
get
equating
this.
to point?
Yes, sorry, can you repeat?
Why are we equating both these to 0.5? I'm not getting.
Your voice is cracking a little bit. I couldn't hear you.
I'm not getting why we are equating both these equations to 0.5.
Okay, so the plane
Because
which
that
I am
is
having
0.5.
is having just 0.5, z equal to 0.5. There is a plane which is this 0.5. There is no x or no y. So it makes our problem easy.
So this equation like x minus xa by xe minus xa is giving that equation of that plane, is it?
Yes, which is intersecting this 0.5 plane. So if this is my triangle, this is the point which is intersecting this plane. This point I am calculating with this x, which is having this x, y value. Good? Because the z will be 0.5 only.
Okay, the plane is intersecting z is equal to 0.5, right?
Yeah.
Okay.
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 Cool. So the last question is, we have the same question, this same type of question is given in your assignment, in your PDF, the study material as well. So I'm not going into depth. So it's just 4 points are given. So first you need to find out. So this is my coordinates. So 2, 1 means this point. Then it's 3, 1. So this point. This is the line I'm having. Next is 3, 1. Either I need to find out 3, 1. So that is this line. So from 3, 1, I have 3, 2. So this is the line. Then from 3, 2, I have 2, 2. So this. And then from 2, 2, I have 2, 1. So 2 and 1. So this is the plane that I can draw from here, which is shown here as well. Okay. And now if I just correct, so the answer will be this one. I'm just getting this square. And if I rotate from here to here, I'll get this 2, 1, 3, 1, 2, 3, 1, 3, 2, 2, 1, 3, 1, 2, 3, 1, 3, 2. 2, 1, 3, 1, then 3, 1, then 3, 2. And lastly, I am reaching the 2, 2. And if you start from here, because as the rotation goes like this, so if you start from,
Sorry, I could not able to get.
Okay. So I have this point, right? 2, 1 and 3, 1. This is my one number. Okay. So basically they have given these triangles. And if I connect all these 4 points, you will get a square. You have to just connect the points 2, 1, 3, 1. So if you just draw a random coordinate system, so this is the 2, 1, 3, 1, 3, 1. Then this is the 3, 3, 1, 3, 2, 3, 1, 3, 2, 2, 2, and then 2, 2, 2, 1. So this is the square I'm getting. Now they have given the triangles also. The triangle says all the z as 1. So I don't have to consider the z coordinate. I have to just consider the triangle. So now if I just show you this. So this is the triangle that I got. This much you understood? How did I get the triangle? How did I get the square?
By connecting
Yeah, this
all
I understood.
lines.
Yeah. Just by connecting the points. Now I see this. This is another information they have given me. 3, 1, 2, 1, 3, 2. So 3, 1, 2, 1, 3, 2. Okay. 3, 1, 2, 1, 3, 2. This is the triangle. And then they have given another equation, which is 3, 2, 2, 1, 2, 2. Sorry. I forgot. 3, 2, 2, 1, and 2, 2. So 3, 2, 2, 1, and 2, 2. So this is another triangle. Okay. Now, from the previous class, did you remember that how we write it and then how we find out this is counterclockwise or clockwise direction?
Counterclockwise direction.
Yes. So this is the counterclockwise direction I'm getting. Here also it's counterclockwise. This is also counterclockwise.
Ma'am,
So that's why I have
for
put this arrow.
counterclockwise,
Okay. This much is clear. I have put the arrow like this. That's why.
ma'am, does
Yeah,
it
clear.
matter?
Now I am clear.
There is one doubt, I think. Somebody tried to ask
Does
something.
does it matter from which point we start from counting counterclockwise?
It doesn't, it should matter because this is the intersecting point. So whether you start from here, if you start from here, that is also one triangle. But this is the start point we have written because here also the start point starts with 1 and 2, 1. If you see these lines, it says 1, 2, 3, 4. So 1 is starting with 2, 1. That's why I've just written 2, 1 is the start point. Okay, if they haven't given anything, then you can put anything. But they will give you because you have to have the starting point. Right? So now
Okay.
I already know this is counterclockwise and this is starting point. So I just put the arrow like this. When I have put the arrow, now if I want to say that this is the facet that I want to tell you about to the software, then P1 is that plane. So it's 2, 1, it's 2, 1, 3, 1, 3, 2, 2, 2. Okay. And if you want to draw another, so as the option says another, so it says 4 edges are obtained by an intersection between the horizontal plane Z1, 2 triangles from STL, few lines of the triangle from are given. The intersection points are given below. So now if we have to make another, then this rotation is counterclockwise. So my next second starting point will be this point. Now, if I start from this 3, 1, then my points will be 3, 1, 3, 2, 2, 2, 2, 1. It's 3, 1, 3, 2, 2, 2, 2, 1. So this should be my correct answer. Is this clear? It's simple, but it's a little bit complex. So you have to just think peacefully. Understood? No comments?
Understood, ma'am. Thank you.
Understood? Yes. Okay. So thank you. Thank you for attending. These are my mails. You can just drop a mail if you have any further doubts. We'll meet you in next Friday. Good night. Goodbye.